the tab where you're in or whatever. Also, if you have a friend that is interested in this stuff, it's time also to give them a link to the show, because this is not going to happen very often, I fear. Today we have a few people that have been working on all the Apple Silicon stuff for Zig, and these are all interesting times. And so I guess it's time for me to introduce them and kick off this second half of the show, which we titled Pirates of Apple Silicon, which is a reference to a movie that if you haven't seen, you should probably see. So our first guest that I'm going to present is Andrew Kelley. So you probably know him from this programming language called Zig. So hello Andrew.
Everybody.
Hi. Then after Andrew, we have Frank Denis. So Jedi Sector 1. Hello,
hey everybody.
Frank. And
Hello.
finally, we have Jakub. Frank, feel free to say on webcam. Don't worry.
Hey, works.
Yeah, it works. So Jakub is from the actual Apple Silicon Mac. Crazy.
Yeah, I'm running on ARM now. So it is crazy, actually. Yeah. Don't shake your head, Andrew. It's pretty crazy. So.
Okay, we already have a.
I've got no software pretty much because nothing works. So. No.
Okay, just a quick reminder for the people, for our guests, guys. If you want to keep Twitch chat open, feel free to do it so that you can read comments in real time. Up to you what you want to do. We already have a comment by Matt that he said to Andrew, "Sick walls, bro."
Oh yeah, thanks, Matt. Okay, these things. Can I talk about that for just 10 seconds?
Sure.
Because these things come with these little tiny sticky things, but there's no way to take it off. So you have to do this painstaking process, and you have to put 5 on each one. And it took me many hours to put these panels up.
Yeah, just wait until they start detaching themselves from the wall. That happens too. Okay. So I guess you can start. I prepared a short introduction for the topic so that people can get up to speed. It's not going to be super serious, but then after I'm done with this, we're going to start with the actual serious talk. So the year is 2020, and a lot of weird things are happening, from the big and obvious ones down to the technology world, where Apple has just released Apple Silicon, a new architecture with amazing performance. Now, has Apple really punched more in the face and given us room for at least 5 more wasteful layers of software abstraction? Or was our perception distorted all along by the constant gaslighting by Intel, who had a stranglehold on the market and preferred choking the competition over improving the design of their CPUs until the strategy quite literally melted down? Well, posterity will judge. In the meantime, back to Apple, new CPU. That's a good thing, right? Well, it's Apple we're talking about, so there's always a few buts. First of all, it's a system on a chip, which I'm sure at some point an Apple exec must have described as a good opportunity for us to make third-party repair even harder. The SoC incorporates a CPU with 8 cores, a GPU, a neural engine, which is basically the modern equivalent of a math coprocessor, and of course also the main memory. So as long as nothing breaks, we're fine, right? Well, almost. Apple decided to take one of the extra 5 layers for themselves and added a code signing requirement to all executables and share libraries running on Apple Silicon. So if your executable doesn't have a valid signature, it gets killed by the kernel. Today, we're going to chat with the fine people that have been tackling this problem in order to allow others like me to use Zig, because yes, despite all the sarcasm, I too bought one of the new Macs because I still think it's the best choice for me, at least for now. So, how was this introduction? Too much?
That's good. It's good. Well, thanks for thanks for that.
Yeah.
Well, so I just want to talk a little bit about how the Zig project itself thinks about this platform. So, for me, I have sort of a bigger perspective where I'm thinking about Mac OS, but I'm also thinking about Windows and FreeBSD and Linux and any operating system that any of our users want to use. And so, from my perspective, I want to provide a development experience for everyone that works the same to the extent that is possible on every platform. So, for example, one thing that Zig is able to do is cross-compile, and I want that to work everywhere. So I want you to be able to be on Windows, cross-compile for Linux. I want you to be able to be on Linux, cross-compile for Windows. But the same thing goes for Mac OS. I want you to be able to cross-compile using your Mac OS dev machine for other operating systems. I also want you to be able to cross-compile targeting Mac OS on the other ones. So from my perspective, I just want all of the things that you can do in Zig to work everywhere. That's how I'm coming at this. So as far as these new changes by Apple are concerned, my attitude is like, okay, what new problems do we have to solve to maintain the development experience on this new platform? And but the thing is, I do want to support this other platform because, if you look at the ziglang.org website, the tagline says that it's a general purpose language. And to me, what that means is you can use this language for any programming project. You can use it with any hardware, and you can use it for any processor, and it will be a language that you can solve for a wide scope of different kinds of use cases, including 64-bit ARM on Mac OS.
Okay, thank you, Andrew, for the introduction. So let's see what Frank has to say. So Frank, well, people from Showtime should know you already if they didn't knew you before. I think you're already more famous than all of us in here. But I think I'm bringing this up in this case more precisely because you have been, you maintain various open source projects, right? So like libsodium and so what's the whole Apple Silicon deal like? And also, since you had to maintain all this software, I know that you got a development transition kit from Apple a while ago. How was working with it?
So yeah, I maintain a bunch of projects, mainly around cryptography and security and privacy. And what they all have in common is the fact that people want to use them on Apple devices, not just on macOS, also on iPhone and everything. So I noticed that whenever Apple announces a new version, a new major version of their operating system, they tend to break stuff. API break, or they introduce new requirements for developers. What by requirements, for example, I mean signatures. This is something that we had to do just because whenever you download something using a web browser on a Mac, it's going to be quarantined. And if you want to run an application that's been quarantined, users will see a pop-up saying, hey, do you want to run this? And of course, you can tell users, like people who already trust you, hey, this is safe, just ignore the warning, say okay. But people eventually want everything to be signed. They don't trust you if this is not signed. So it turns out that to sign something, you need to register for an Apple developer account. And then you need to use Apple-specific tools to do that. And your applications need to be signed both by you using your own key and by Apple, which is okay. And then they introduced another requirement later, which was notarization. This is essentially some kind of static analysis that Apple does just to verify that your executable is not going to do some shady stuff. This is not bulletproof, but still you have to do it. If you don't do it, you still get the pop-up. So Apple likes to introduce new things that developers have to go through every time they want to release something, which is why when they announced Big Sur, I was like, okay, this is going to break things. This is going to introduce new requirements. So just to get prepared, whenever they announced the DTK, which is a development platform for ARM, I registered for getting one. So this is a Mac Mini with some ARM CPU. This is not the M1, this is a slower CPU, but it was still a great platform to test the software on, and also to test software on Big Sur. And I was at first, pleasantly surprised, because anything written in C or C++ or Swift, essentially anything that you can compile using Xcode, worked pretty much out of the box, which was a very nice surprise. No big API breakage. There was some breakage. For example, the way dynamic libraries are provided is slightly different. So for Zig, we had to do a couple tweaks to get it to run. So these were tweaks mainly for Big Sur itself, not specifically for the ARM version of it. And once we had this running on Big Sur for x86, 64, it was pretty straightforward to have Zig actually work on Apple Silicon. So that was really cool, and it was great news. Everything seemed to work perfectly. Until a pretty late version of the Big Sur operating system, I think it was right before the first release candidate, things started to fall apart. Whenever you wanted to start something, half the time your executable got killed with a signal 9. So you wanted to run Python, poof, signal 9. So when I noticed that everything was in a pretty weird state, I was like, okay, maybe this is my DTK. Maybe my operating system is totally in a bad shape. And I was talking to Jakub about that, and he didn't notice the same thing. Everything was working perfectly on his system. So, okay, so far so good, it has to be me. But after an update, eventually everybody was seeing exactly the same issue. Things were just killed by the system. Nothing in log file, nothing, just kill with a signal 9, which was very frustrating. So it turns out that in order to work on this problem, you have to go through another requirement, which is that every single executable, including shared libraries, has to include a hash of itself, which is kind of weird, especially since this is just a hash. This is not a signature, so anybody can compute a hash. Plus, this is something that only happens on Apple Silicon. With exactly the same version of Big Sur on other platforms, you didn't see the same problem. So that was a little bit weird. And at first, my reaction was like, okay, that has to be a bug. This is gross. I don't know why Apple would do something like that. Doesn't make any sense. It will be fixed in the next version. Of course, it wasn't fixed. It's still around. As of today, I have no idea why this is something that happens only on ARM CPUs and not on other CPUs. This is still weird, but you have to go through it. So this is one of the reasons why most of the languages, besides the ones provided by Xcode, just don't work on Apple Silicon yet. If you want to run Go, it's not going to work, even though you can cross-compile to ARM for OS X already. That works, but it's not going to run because it's not going to be consigned. Rust didn't work until very recently, and by very recently, I mean last night. And this is just for a nightly version. And they went through a pretty ugly workaround, which is using the system linker, which is what we did originally. So yeah, there's still a bunch of things to do to cope with Apple requirements. And I think that Jakub is going to tell us a little bit more about them.
Yeah. Thank you, Frank, for this quick recap. Yeah, what a mess. By the way, so let's continue with the main presentation so that we can show the full state of things. But later, I want to ask you to please try to think of a good reason for Apple to do this, because I think we are, at least I'm baffled by this choice. And I can only put my tinfoil hat on and think that this is like the prelude for a new Apple tax that's coming to everybody. But I hope there might be other interpretations. So I'm looking forward to hear that for you later. Okay, Jakub. So I guess it's finally time for the main star of this show to show us.
You mean the demo?
Yeah, show us the demo.
Not me.
So what are you? No, actually, you are really the star. So you have been busting your ass doing this stuff. So please tell us how much effort you put into it and how far you got.
So yeah, so Andrew knows this very well because I've been ranting to him for the past 2 or 3 weeks. I can't really remember. And Frank as well. I've just been messaging them, going like, "This is insane. I don't know what's going on. I don't know what's happening. I hate this. I hate Apple. I just want to throw everything out." As Frank said, actually, there is nothing like this embedded within the kernel on x86-64 for some reason. It's only on Apple Silicon, so ARM64. I think it might be some integrity checks. Frank will be able to tell you more about this, but it looks like it because so one of the interesting things that we noticed with Andrew, and then actually this is kind of exciting. So I was ranting so much and I was shouting so much that actually Apple wrote to us. So Apple engineer with some high up engineering manager actually pinged us an email like a week ago or something, telling us, hey, we can help you. Obviously, I really appreciate this stuff. It's just that by that time, I went through everything that he suggested. Basically, I had a look at everything that was there within the Apple open source. He also mentioned that all of this stuff that's been added, it's not out yet. They still have to sift through it before they actually release it. I don't know why it's meant to be open source, but never mind. So yeah, there's a couple of changes. The most important thing is the fact that, for us, this is a bit of a problem, but I guess we'll have to live with it anyway, is the fact that it has to be a PI. So it has to be every binary and shred library, of course, but binary as well, has to be a position independent executable, meaning that this very clever trick that Andrew came up with for incremental linking is just not going to work because the kernel doesn't like it. And that's it. So so that was the first thing. So we had to figure out how to actually go about not using absolute addressing at all in the linker. The next thing was, as Frank mentioned, codesigning. This was the most baffling thing because I still don't get it. I implemented this stuff and it works and it signs the binaries and they work, but I have no idea why they added it. No clue. I'll show you guys what that it runs and incremental linking as well.
Mm-hmm.
So as Frank mentioned, it's essentially like
Are you sharing your screen, Jakub?
No, not yet.
Okay, let me know when you do because I might not notice. Thank you.
Okay. So now I'm gonna run for a bit and then I'm gonna share the screen if you don't mind.
Sure. I didn't want to pressure you.
I need to vent out. It's been like 2 weeks or 3 weeks.
Please do. Take your time.
So with the hashes, it's actually you have to. Oh, and this is great. So in ARM, every page is 16 kilobytes. On x86-64, probably some of you have noticed, it's only 4 kilobytes, right? So when we actually create a Maho binary, we have to basically have everything aligned in 16 kilobytes pages. Awesome. Okay, that was one of the things that was missing, and it actually wasn't explained anywhere, and I totally forgot about this. But with code signing, you split it into 4 kilobytes pages. So, and nobody can explain to me why. So we're code signing for ARM, and we have to segment that into 4 kilobyte segments rather than 16 kilobyte segments, just to make the binary bigger for some I don't know. Yeah. So that's what you do. You then calculate the SHA-256, and that's it. That's basically what code signing is. This is not the end of the story here because if you do any sort of in-place patching of the binary. And this is actually what most of languages had a problem with. That's Go, I think Rust as well. That's why they went with the system linker. It turns out that if you modify the binary or anything, the inode gets cached by the kernel, and if you do anything to it, everything is invalidated and you get SIG kill 9. So a resolution to this is basically a copy and rename. And thanks to Lemon Boy, he showed me that my code, I don't know, like 20 lines or something, can be written in one line, and that was beautiful because Zig is so nice that copy file does everything for you. But basically, we have to do this. This is insane. Like we can't patch in place. Even if I recompute the code, like the code signature, what I do, that doesn't matter. The kernel will still kill you because the inode is saved somewhere. So you either reboot or you copy it over. It's yeah. Homebrew had so many problems. It's fixed now, but Frank remembers I was basically, I wanted to shoot somebody because I had to manually, after every single installation, like of dilets or something, I had to run like a find and then, recalculate the code signatures and copy everything over. I was like, why? But anyway, right. Let me share my screen. So that was a bit of a rant. Okay. Can you guys see this? And I'm asking here Andrew and then Frank, if you could confirm that everybody can see this. Is it okay?
Yep.
Cool. Right. So first of all, I've got like as I already told guys, I've got unsolicited demo here as well that I kind of hacked together today. Before I get onto this, let me show you that actually stage 2 can do this now. So that's been marked, I think, yesterday. So thanks for review, Andrew. That was very useful. So there we go. This is whoops. Sorry. This is the stage 2. It's pretty fresh. So let's do the cool stuff. Oh, sorry. I'm going to show you first what the hello is. There we go. It's essentially the same thing we have on x86-64. I'm not using I don't actually use any weak or lazy symbols yet. So I actually don't use the calls from libc yet. Actually, we use syscalls directly, which we shouldn't. But whatever. It's the first step forward anyway.
Yeah, Jakub,
so,
let me just add one thing for the people that might be watching on YouTube later. So this is not how normal Zig programs look like. You're not always supposed to just use assembly inline.
For me, they look like this nowadays.
Yeah, but this is an example that's supposed to run in the self-hosted compiler, which is still a work in progress, and the self-hosted compiler doesn't support yet the full syntax of Zig. So when testing, developers working on the stage 2 compiler use simplified examples where they use inline assembly basically to jump over parts of the language that are not yet implemented. Yeah, please continue.
Okay, cool. Right. So thank you, Lars. Yes, that's correct. So this is the equivalent of Hello World, just written for ARM, specifically targeting Apple Silicon. Then again, there isn't that much like arcane knowledge here. I think the only thing is that so SVC is the equivalent of syscall. If you target Apple Silicon or Mac OS, you have to. So the immediate here is actually 18 hex. That's it, right? So in register 16, we're sticking the syscall number for write. Then we have DFD, the file descriptor that we want to write to, which is 2, which is 1. Then the pointer to the message, and then the length of the message, right? There's absolutely no magic here. And then exit is basically the exit syscall, so that's syscall number 1. And exit, well, we're going to succeed, right? 0. I usually actually stick in 42 just for fun, but then, obviously you have done something fail. Anyway, so this is very simple. So let's do, so for those of you who have actually not seen stage 2 in action, we do have a thing called incremental linking. I was going to say that this is actually something different than compilation, like incremental compilation, because we actually do in-place patching. Well, in case of Apple Silicon, we actually cheat you in a way that we do some in-place patching, but then we have to copy stuff over, but you won't see it because we're that sneaky, right? So hello Zig, and then if you do watch, then basically you can then do update and recompute only those symbols that changed or those sections. Not everything is implemented yet, so you might very easily break this stuff, but some things. But we're gonna work on them. So there we go. We should see the hello. So this works. This is native executable. Just to prove you that I'm not lying, I'm actually running natively, not via Rosetta. So everything is awesome. Now let's do a quick tweak here. So let's print the message twice, and this is the power of I guess Zig's incremental linking. I don't think anybody's got it, and this is absolutely brilliant. We just do update, and you can see that actually the list of operations is actually much shorter than it was. Obviously, I recompute the code signature in full. I don't think we have to because we've got a lot of like 0 padded space, and I'm pretty sure the hashes won't change, right? So we could probably just cache that as well somewhere, but that's for the future. Anyway, so and there we go, works as well, right? So we can actually have fun here and change the message as well in the pointer. That's what, +3, 17, I think. Update, a bit more change, but there we go. Okay, and we can just keep going and on and on and on and on. So all of this stuff. So this is a pie. Let me. Sorry, you guys are gonna see probably yourselves, which I probably shouldn't do. Right.
No.
There is this thing called Mako View. And it's a pretty nifty tool. It works only on Mac, unfortunately, but it basically puts everything into perspective. And if you're debugging, if all you get from the kernel is that something got killed, that's not very useful. You could probably debug the kernel, but then again, you need another Mac to do this. So I'm not sure whether there's any marketing strategy there that to debug your Mac or the kernel, you have to get another one. But we're gonna get there. So yeah, there you go. We've got the code signature. You can see that a lot of the hashes is actually the same. That's because we've got lots of zeros here. That's because we do pad it for the future recompilation purposes, so that we don't have to extend the sections and move them around, because that's that requires a lot of reads and writes. So we don't we want to shave off the number of syscalls to the bare minimum. And there is the code, the assembly here, and I'm not going to go into a lot of the detail here, but basically so instead of having absolute addressing, we kind of what we have here in God, instead of storing the addresses, we actually store instructions at the moment too. So we still fit in 8 bytes. It's essentially a jump table, relative jump table. So on x86-64, it's done the same way. So you're also going to get a pi, and it's using the RIP relative addressing, whereas on ARM it's obviously PC relative. But anyway, and if everything is relative now. Okay, so we kind of saved the day, I guess, a little bit, in the sense that we didn't have to go for embedding the actual jumps within the assembly of text itself, like the actual code itself. Instead, we actually have it in the God, so we don't have to change everything every single time. Okay, cool. So so that was the incremental linker. What I did today, and if there is any LLVM that watching, please don't hate me. I promise that I will try my best to port this stuff to LLVM itself. I didn't yet. So for those of you who don't know, so as Frank pointed out, and with Rust, they swapped the LLVM LD64 for the system linker, and that's what we did as well. Essentially speaking, if you do export this variable, set it to 1 so that it's actually there, we also swap the LLD for the system linker. But this is not cool. So actually, believe it or not, so this is the standard Zig code, right? This is as Loris mentioned, this is what you normally write. You don't write inline assembly. So bear with me here. I'm not cheating you. This actually works. So as you can see here, we are using LD64. So this is the LD linker. And well, guess what? It works. So I did what I promised Andrew I would, or maybe I didn't. Maybe I said I won't. I can't remember. Basically, I do so after the LD spits out the binary, I did the patching myself. So I created the code signature. I parsed the Mako back. I calculated the hashes. I put them back in, and then did the copy trick, and there we go. So essentially speaking, maybe we could for 0.7.1 use LD itself rather than using system linker hack for some basic stuff.
So basically, instead of let me see if I got this right. There are basically the normal option for codesigner and executable is to call the codesign utility or use the system linker, which basically kind of does the same. Maybe it doesn't call out a different process, but at the end of the day uses Apple stuff. While you basically wrote codesign.zig. Is that?
Yeah, essentially, yeah, because we already have it, right? So right. I just basically, so for those of you who might know, I'm working on this kind of like Mako, like thermal-based Mako view called Zacko. I'm really bad with naming, so sorry for this. It's basically Zig's Mako parser, and I just took the code and I put it in the the linker itself here. And after the run with LD64, I call it, I parse it, I scan the file. It's very easy to add this stuff, provided that there's enough padding. I allocate the space for the code signature, then calculate the hash, fold the scrap, put it in, then there we go. So actually, and there is another thing. I didn't have enough time today to do this, but we didn't actually. So with Andrew, we got really close to be able to cross-compile for macOS x86-64, like really close, because we got the headers out. We actually ship them right now, but there is this problem with LLVM's linker that you can only link to libsystem if you're on macOS, which you don't need to. I mean, with the frameworks, we're going to have to probably, try a bit harder, but for libsystem, it's actually pretty easy. And we can also do dispatching here. I know this is not the ideal solution. We should probably, we definitely need to backport this to LVM if nobody else does, but it's possible. So hey, there you go. Right, rant is over. Sorry, I'm gonna switch this back to no screen sharing. Wait, there we go. So yeah, I should probably say because your birthday was I don't know, Andrew, a couple of weeks back. So yeah, happy birthday. There you go.
Wow. Wait, so you actually we're running the LLD linker, and then it finishes the job, but it's not finished. Then Zocco code loads it again, does the code signing, fixes the, well, you're not yet, but you're thinking this is the next step. Fix the L system.
Yep.
Holy crap! So we're gonna have the ability to cross-compile for macOS after that.
Yeah, we should. Yeah, we just need to extract the headers as well, because I didn't have time to do this, and this is pretty boring. So I'm gonna leave that to you.
Oh, fair enough. Wow, what a great birthday present!
Wow. Okay. Nice. Holy cow. That is a lot of work. So
yeah, Frank. Sorry, I'm just gonna quickly. So yeah, Frank, we're better than Rust now. I'm just saying.
Okay. So let me see. We have. We want to make sure to. Sorry. Every single time this bug Discord. God damn it. Okay. Let me make sure that we don't forget to mention. We don't forget to skip pieces. Okay. So, but Jakub, from the point of view of performance, how does it feel to you? I know this is still an incomplete state, so maybe if you don't feel ready to comment on this, just say so. But previously, the general idea of incremental linking is we are not even rewriting the entire executable, right? We're just writing chunks of it. And that seems great. But then to make this stuff work on macOS, now we need to recompute a signature, copy and paste the file twice. Do you see these impacting the performance of incremental linking in a way that kind of detracts from the expected user experience?
Well, not yet, because the stuff I'm working on is pretty small. So when we're gonna get to bigger projects, we'll probably notice it then. But we can still optimize that anyway, because it's basically, so we are still doing in-place patching. It's just that we have to go through this additional hoop of the code signature plus copy and rename, and that's it. So basically a couple more syscalls. But other than this, the Andrew's brilliant idea of the GOT table. Actually, I called it Zig GOT because there's another thing I had to twist. I initially had it, and this is another thing actually. XNU kernel on Apple Silicon is really picky about. Is about having proper protection flags set on each segment. So protection flags basically they describe what the segment is meant to be used for. So the text traditionally and because the naming actually doesn't matter, it can be called whatever you want. But traditionally, text is where you have the executable code, and that's why it has to start with execute and read. Data is for all your statics or globals, and it should be read and write, and then the link edit, which is basically this one's got all the crap that link the DYLD, so the loader is actually using this space for is I think it's read initially, and then it bumps up to 203. So basically initially we had the GOT in the data section. But we can't now because they're not addresses, they're actually instructions. So we have to have it in the text section. So it has to be part of the executable segment. And that was one of the things I had to change, but it's fine. I mean, to be honest, it really doesn't really matter. With ARM, we're going to have to work a bit harder on the actual assembly itself because the jumps, even relative jumps, are not that easy. We don't get that much leeway as we do with x86-64. We don't get like 32 bits. Basically, if you want to jump like a couple of pages, we have to perform like I think 2 instructions instead of 1 because we have to jump to a page, and then from within a page we have to do a relative like small jump or something. We'll get there. So I think we're gonna be fine, except for the additional syscalls. But I think that should be fairly minimal. So I'm optimistic. I'm really optimistic.
Do you expect Apple to ever come out with like a new syscall that basically says flash the code signature for this inode?
Oh no, hell no, no.
Okay.
I strongly doubt that.
Okay. Well, okay. Thank you very much. Well, thank you for the exposition, but also thank you for your work. Clearly, I think everybody here is going to benefit from that, especially because if cross-compilation works, then that means that when your Mac craps out because of the latest change that Apple did, at least you can make do with cross-compilation. So that's good. And I actually...
It would be easier. Yeah, it would be easier for us as well, right? Because nowadays we would basically, the way we had Zig compiled for ARM64 available for 07 was because, I did it on the DTK, and this is pretty annoying, and I'm pretty sure CIs will not catch up for a very long time. So generating binaries automatically is going to be difficult unless we have good cross-compilation.
Right. Okay, so let's call an end to the main part where we do the main exposition and explain the whole situation. And I would like for Andrew to just give us a final recap. So we now discovered just now that we're going to have cross-compilation. That's awesome. But I think people want to know in general. So is Zig Stage 1 going to be working for the new Mac app platform and everything else? So what can people expect from the Zig project, Andrew?
Yeah. So, well, before I'll answer your question, but I also just want to address some of what Jakub was just talking about.
Yeah.
So I want to point out that if we get hot code swapping working, that can still work with this new Apple Silicon, because that's the same thing as a JIT, where you change the code while it's already running, and so that use case is actually okay. But I also want to say, if there's any Apple people listening, we got everything to work, but we're jumping through hoops that just make the process slower for the developer, and we have to copy. In order to wipe the code signing cache, we have to pointlessly copy the file and then rename it back to the original name, which just is, if you're a developer and you're doing edit, compile, debug, repeat, it's like, why am I just copying my entire application pointlessly in this whole process? Here's the one specific thing I'm asking for. Join the rest of the kernels in providing a copy file range syscall. It's a great syscall. Everyone's doing it. All the cool kids are doing it. Just give it to us, and it'll partially mitigate the fact that we have to pointlessly copy files around. But yeah, sorry. Let me actually answer Laura's question. So, as far as the Zig project is concerned, we're going to support Apple as long as it's popular with the users. We exist to serve the users, and it's clear that the users like Apple's stuff, so we're going to support it. They introduced this stuff that makes things difficult for us because this code signing, I don't understand what is the point of it. I would love to ask Frank why. Is there any crypto security justification for it? I don't understand what that might be. I'll ask you that in a second. But I mean, just big thanks to Jakub for putting the time in to make things work. So, I mean, we'll do it. We'll do it for you because we love you and because we exist to make your development experience work for every platform that you want. So I'll talk about version numbers in a second. There's another topic though, which is what is the policy for what operating systems do we support? And this was something that Marler was bringing up on IRC yesterday, and he opened a proposal yesterday. He was talking about Windows because right now the policy is for closed source operating systems, macOS, Windows, we support only the same versions that the respective companies support in terms of security patches. The main point of limiting that is just to keep the scope small enough in the Zig project, because we do have limited resources. Like Jakub put heroic effort into making this stuff work during the last few weeks, but that's not something we can just expect or demand of him. That's like something that he was inspired to do and took it upon himself to do it. So we do have to be careful. We don't want to make the scope too big, or we'll drown in trying to do everything. You know, we got to make sure we're making progress towards the milestones that are critical for us to hit. We got to hit 1.0, or the whole project is going to be useless. So for me, I want to make sure we don't increase the scope too much. But that there is a question there, like how you know, and Marler brought up with Windows that Windows 7 still has a huge market share. Maybe we should consider including that. I don't have a great answer for that. I look forward to having a healthy discussion in that proposal that he opened. So as far as I'm concerned, this is an open topic that you know, our community is welcome to, you know, share perspectives and opinions about what you know, what should be in scope, what versions of operating systems should be supported. That's a topic. As far as version numbers go, 0.7.1 is coming up. That's my main priority. I don't think that's going to support Apple Silicon. That's going to be bug fixes only. That's what, you know, when you get a bug fix release, no one should be worried about scary changes. You should always be like, yes, I will always take the bug fix release. It's just bug fixes. But based on Jakub's excellent work, 0.8 is looking like it will support Apple Silicon. And if you want it before the release, you're going to have to track master branch. But we have binary distributions of that. Should be okay. We'll code sign the binary distribution.
Right. New to do. Awesome.
Yeah.
Awesome. Thank you. So, Andrew, just to make sure I understood clearly. So, you said that closed source operating systems, you don't want to support them past their normal lifetime, but there might be arguments in favor of popular versions that they are still in use by a lot of people. Now, this brings me then to then I think that the Windows OS that we should support more than anything else is Windows XP. It's both open source and very popular still.
You're making a joke that the source was leaked recently, right?
Yeah. I mean,
yeah.
If you can get the source, that's open source enough for me. I don't know.
Legal disclaimer: Zig programmers do not look at the source code of Windows XP.
Oh man.
Wait, so I seriously do want to ask Frank though, do you have any insight? Like, my mind is open. Like, what is the possible actual value that this code signing is providing? Do you know?
Yeah, so actually having the kernel keep track of hashes of everything is not a new concept. I think NetBSD has been doing that forever. And the point is mainly to keep a list of trusted apps or trusted files in the case of NetBSD, and untrusted files, so that whenever you get some malware or any way an attacker could have to change files on your operating system, it mitigates the implications. So that's one thing that may justify the presence of hashes. Another thing that they could be useful for is software firewalls or software such as CrowdStrike, where network administrator can say, okay, this fleet of laptops is allowed to run this specific set of apps and not that specific set. So if we keep hashes everything, maybe Apple can provide a nice, clean API to do that. And another reason, and this is probably the main reason in the case of Apple, code signing is not a new thing for Apple. They've been doing that forever. Well, not forever, but for quite a long time, especially on iOS. So this is about real signatures, what I'm going to talk about, which is not a hash. This is a real signature. So you get some app and the developer with their developer account provide a signature and Apple signs this signature. Why do we have to do that? Well, first, a user can trust Apple for having signed something that they trust themselves. So you know that the binary is legit. But also, and this is something we saw recently with like Epic, for example, Apple has the power to say, all right, this developer account is now blocked. So they can revoke developer accounts. But one thing they can't do right now is revoke specific applications. They don't do that because all they can revoke is a specific signature, and a signature, as of today, is just a developer account signature. So they get some finer granularity as to what they can revoke. And the main point of that is, well, for good things, is to avoid malware and in general bad stuff. And it seems to work pretty well. I mean, I'm pretty sure that every single day you have a shitload of people submitting things to the App Store. So either malware or things pretending to be your bank, but it's not the real app from a bank. This is just to steal your credentials. And it seems like this kind of problem doesn't exist in the Apple world, but it probably does. And it's just a bunch of people trying to review stuff, plus some automation, which is what we get with the new notarization procedure, and the ability for Apple to revoke developer accounts. But
wait,
now
so,
we can revoke
one follow-up question.
Yeah.
So why wouldn't the malware try to use an ad-hoc code signing?
So ad-hoc code signing would still be quarantined first. So if you download it from the web browser, which is the main infection vector for malware, it's not going to work. So that's one thing. Yeah.
Wait, so if we provide Zig tarballs on the website, will they work, or do we have to do something else?
I think, Andrew, that Frank was the thing is with current code signing, which is not really signing but just hashing, this is not possible. But I think what Frank is saying is that since they want, even though we are putting our hands into the algorithm and messing around with it, they don't want people to see. They don't want people to get their hands in because they want people to see developers to see code signing as an obscure, like an opaque box, so that they can in the future swap out the implementation, make it a proper signature, which is not currently, and at that point, what Frank was describing can come into effect.
I'm not totally convinced about that, but even with ad-hoc code signing, which is just a hash, it means that whenever Apple decides to block something, in order for the malware to keep working, it has to be changed somehow. So it's an obstacle.
So
yeah, that
I
makes sense.
I just want to add that I didn't set up this Mac to be able to SSH to my Arc Linux, but I can generate the code signature there and run it here, no problem. But then again, I use SCP to copy the files over, and there is no quarantine. So I'm not sure whether does it only apply maybe to downloads from the web browser maybe or something, or maybe apps rather than binaries, because this is just a macro.
So if you use something that's not quarantined, such as cur or whatever, everything you download is not going to be quarantined. If you download something using a web browser, which is what most people do, then everything is going to be quarantined. Which is why when you use something like cur something by sh to install Rust or whatever, This thing doesn't need to be signed. But if you download it from a browser, it's not going to work. Well, it will work, but a user has to say, okay, I trust this. Please open.
Right.
Yeah. Okay.
Wow. We'll see. We'll see how that goes. Okay, so let's now open officially the floor for questions. So if anybody has a question for anybody on stream, send a message, Twitch chat, please, or Discord. Tag me, please, especially if it's not Twitch chat, and maybe also mention if you want any specific person to answer the question. Mention also their name. Let's see. I'm scrolling up the chat to see if there was anything else that any question that was asked earlier that we might want to bring up, but I can't find anything for now. So okay, so the first question is from Felix. Frank, how do you get these athletic? How do you get swole as a programmer?
Sorry, how do I get what?
Very muscular.
I try to work out. Well, I mean, I try when I can go to the gym, but with a lockdown, I haven't been able to do it for quite some time now. So actually, what I'm using, and this is a nice thing to have if you somehow can't go to the gym due to the lockdown or whatever. This is pretty cheap. This is just, elastic bands. So with different resistance, and you can do a lot of different things. Practice your legs, whatever, with this. So that's pretty cheap. It's convenient. It's lightweight, but it's not the same thing as having real gear, of course, but it helps. So yeah, that's my trick.
Thank you for sharing. I think Felix didn't expect such a detailed answer. Oh, doing legwork while programming, nice.
You were ready for that question. You had those props just sitting right next to you.
I wasn't ready, I swear.
Oh man. Okay. So I think Frank, you probably made the best argument possible in favor of how Apple, or a good reason why Apple wants to lock down its systems, and one good effect that comes from that. I also have to say that even though, so probably for the people watching and everybody probably watching this video, I don't have to explain the problematic things when it comes to Apple, the Apple Store, locking down a system. Like, you buy a system, but then it's not even yours. You're just leasing it until then you give it to the landfill, or you give it back to Apple for 25 cents. But the positive side is really there, and I personally can see this not just when it comes to malware, which maybe I don't know, when you are a developer, when you're a programmer, software engineer, you like to think that you don't fall victim of phishing and stuff, even though maybe occasionally you do. I have to say, I had to wipe once or twice my Windows machine because I got one of those nasty things that lock you out of everything. You can even open the task manager anymore. But I think in the Apple world, you can see that even in other situations where I think that for people there are, what I'm trying to say is that there clearly a benefit for when for a system used by somebody that is not maybe super tech literate. So you give a computer to your grandma and you know that she's not going to get her money stole by a fake bank app, probably, or at least that the chances of that happening on a Mac are lower than happening on a Windows PC. But I think that also for people like us who are not super affected by this type of problem, I think there is also positive for us when it comes to apps that do the worst that they can while not breaking the law, in a sense. Like, I think I'm I'm very disappointed every time you have, like, for example, apps on Windows that you try to install it, install the application, and then it tries to drag in a bunch of crapware or other applications that try to do things that in the Apple Store, where you have reviews, where you have a system, they would probably not attempt. So I think there's a benefit there too. That said, Apple is Apple, and Epic learned that the hard way, I guess. But they asked for it, so they wanted to get their account disabled. So we'll see where that goes. But yeah, interesting times, and I think there is no one easy way of looking at the whole problem and just come out with a easy answer to everything.
I think that's fair enough to say, but I also want to present the other angle, which is
Please
my
do.
angle, which is that I think every CPU cycle spent on code signing and validating signatures in the kernel is just a wasted CPU cycle. It's no good. Hate it. And I don't want to give power to Apple. I want more power for myself. I don't want the power to be in the proprietary kernel code where they just push a release and then now they decide what you can or can't run on your hardware. No good.
That's also reasonable. I mean, we probably should see at what the jailbreak scene is going to bring us in that regard.
Oh yeah,
So,
I actually have a prediction on that. I predict that very soon there's going to be a shell that is a loader. So in the shell, everything you run, the shell is being like the kernel. It's parsing the ELF file. It's because it's position independent executables. So it just ignores the code signature and it just loads all the sections. It's somewhere in memory and then jumps to it. That's my prediction.
Jakub, you wanted to say something?
Oh no, I was just gonna jump on the bandwagon here and say that yeah, for typical users, it's fine. You've got Rosetta, so you don't have to actually everything works. But if I want to use ARM and I want to actually M1 is pretty impressive. Like I have to admit, like I recompiled LLVM yesterday 3 times. Yeah, Frank says that this is my fetish. Maybe it is. I don't know. It was my mistake once, and then I just did it twice again. It actually took only 20 minutes. And this is on the MacBook Air, no fans, nothing like this. And it's very impressive what you can do with a system like that. If you design it yourself, that's cool. But yeah, but at the same time, Apple has got everything vertically integrated now. They own the entire stack, I think, right? Do they? I think so. Maybe except the screens, not yet. But they got everything. Like so, basically, yeah, it's like leasing that thing, even yours. So
Yeah.
so I don't like that. I would like to take full advantage of the hardware that I get, but I can't. So
Yeah, well, you mentioned the screens. I don't know if they produce them, probably not, but they also have their hands in there. Like, if you watch any video about repairing Macs, you'll see that like new Apple hardware. And I think this is not. So I'm not 100% sure if this applies to the laptops too, but I think it applies to the new iPhones at the very least, which means that probably it's gonna get everywhere, even where it's not right now. What they do with screens is that they have serial numbers, like they write the serial number somewhere in the memory of the phone, and if you boot it up with a different screen, even if it's a perfectly legit original screen by Apple, but if the serial number doesn't match, the phone refuses to boot. And even with the camera module, I think there was a video where you could see the phone, like not only what the phone did was like show error messages, which kind of seemed like the phone was kind of malfunctioning. But the phone wasn't malfunctioning. The phone was just refusing to use a camera module that was not the one originally installed. And so if you want to have any kind of repair with your phone, the only thing that you can do is go to an Apple Genius whatever par and have them tell you that you had water damage on them, even though you didn't. No, I don't know, but there's stories about all this stuff. So
actually, I have to defend it. Like they're actually pretty nice. Like customer services of Apple are pretty good. I always had good experience with this. But the fact that you have to go there and basically they have to tell you like, no, sorry, you have to replace the battery, and then basically you have to shell out for the new iPhone. So I'm like, okay, I could do it from home then. What's the point? But I guess whatever floats your boat, right? Whatever you prefer. If you want, like, not worry about stuff, you just pay Apple and that's it. That's you done. And I'm pretty sure many people actually do that. Yeah.
Hey, wait a minute.
Anyway, what? Sorry.
Well, am I just the token non-Apple user in this? I just realized that's my role here, isn't it?
Yeah.
I think so, yeah.
No, I'm middle ground, so
yeah. Frank, what's your take on Apple systems? Love them, hate them?
I hate them. No, actually, I love them as a user. I hate them as a developer because the documentation sucks. But as a user, they just work.
I'm sorry.
I don't have to worry
what
about
docs?
documentation sucks.
What documentation?
Well, of APIs in general.
It's the joke.
And if you're looking for specific examples, you're better off going to Stack Overflow rather than their own documentation. But other than that, the hardware is great. The quality of service is great. I mean, yeah, and as you said before, if you want to recommend something to someone who's not tech savvy, it's a good choice. Yeah.
Mm-hmm. Yeah. I have to say, so Andrew, I think that probably you won't find, I think, many people that are software engineers that are in tech that really love Apple, but you find people that are willing to just work with the flows. Like, let me tell you, for me personally, when I was in university, and before that, I used to hate Apple. I used to really genuinely hate Apple. I remember I had in my class this guy, which we call the guy, we nicknamed him Apple Man. And this guy had every single Apple device. He would wake up during the middle of the night for a new Apple release and go there. And I remember like he was, I don't know, like the antichrist Christ for me in a sense. And but after that, and here's I think the interesting thing. After a while, I actually realized that my hatred for Apple was, I was losing the game. I was losing the same game that I was thinking I was winning. And what I mean by that, I mean that Apple is clearly, well, obviously Apple is good at branding, and they build their brand, and I mean they're probably the best on the planet doing that. And I hated all the followers, all the mindless zombies that they created. And what I failed to realize for a while is that even though it was it was the inverse process, it was by negation, I was kind of the same in hating them. I was being, my behavior was affected by their brand. So at one point, I decided to let go, and I had this Dell XPS 16. This laptop was nice, but if you used it for too long, for some reason, the part underneath the trackpad would heat up and it would start burning your fingers after a while. Like, I remember feeling my fingers burning while using it. It had plastic thingies at the sides that would that also, because of the heat, they would the glue would give up and the plastic things would fall apart. I had Ubuntu on there, and this was the phase where Ubuntu was I think switching from GNOME to whatever the hell they had after. What's it called?
Unity.
Unity, thank you. Unity, which I hated. And then I also had a kernel module for Wi-Fi, where the Wi-Fi had two switches, a hardware switch and a software switch. And for some reason, the two switches would get out of sync. So whenever you enable Wi-Fi by touching the button on the laptop, which would turn on the hardware switch, you would toggle off the software switch, and vice versa. Only solution, reloading the kernel module every time. So at one point, this was my life, and I said, and that was when that was 2012, when the new MacBook Pro Retina, the first generation, came out, and I said, you know what? Fuck it. I'm gonna switch to that. And it was a happy dumb programmer with a Linux surrogate for a long time. The only moment where I started, where you made me hit a limit on the Apple system, was when we were trying to debug a executable, and then you try to get GDB running on Mac. That doesn't really work. hangs.
It will
for some-
never work now. I'm just saying.
Oh, nice. So
Yeah.
awesome. And the debugger wasn't working well. But before that, I never actually hit that limit. So I don't know. I think that's where we are. I think everybody that is using Apple just wants the nice stuff. Maybe they want Office, and they don't suffer the bad part too much. But Apple is changing that equation, so we'll see.
I'm gonna quickly jump to Andrew's side here. So for me, that point was 3 weeks ago. With Apple Silicon and stuff. Actually, honestly, I took a beating because this is horrible. That's why I was joking to Frank. Like, what documentation? There's none. I'm sorry, but nothing is documented. I was reading the code, learning like what the hell's going on. But anyway, you mentioned the heating problem. So yesterday, because I've got this fetish with LVM stuff, I left the laptop on. You know those I don't know, do you guys have them? Like those hot water bottles, that you use for like you put the hot water in and then you use to warm up and stuff. The classic stuff, right? I put my MacBook Air on the chair, and I came back. I picked it up. Actually, it was compiling LVM. It was really comfy and warm. So they also do tend to warm up a lot. So with Apple, I tend to find that the hotspots are not near the trackpad; they're closer to top of the keyboard, and they had the same problem as well. So I think the heat dissipation thing is just it's everywhere. There's running around.
That I agree. But having the trackpad heat up, I assure you, it's like if I'm going to hell, I'll get that. I'll get a laptop in hell.
You should use Vim then, What do you use trackpad for? I don't know. I mean,
yeah, I knew that somebody would bring this up. Yeah, this shows another weakness, I guess. But sorry.
My attitude on the whole thing, it's not that I have a side, right? Because I mean, here, look, I'm gonna move my webcam for a second here. This is my Linux desk. I got Windows over here. I got a table set up here with a MacBook Air, an old one, and a spare computer to put any operating system on it. And then that empty table right there, that's for the new M1 that's coming in the mail next week. Like, my attitude is I have to support everything. I have to test everything. And I'm just annoyed at how much more work I spend on Apple stuff than everything else. That's my take on it. It's not sides. It's just like, man, how much hoops do I have to jump through for this one thing?
Yeah. And one more hoop to jump through at the next Apple keynote.
Yeah, exactly. Yeah. Although I will say, I actually am looking forward to supporting 64-bit ARM Windows. We actually have a head start on that thanks to the MinGW project.
Nice.
Cool.
I already saw an article of someone managing to install Windows on their MacBook M1.
Yeah, I think Frank tweeted this stuff. I think it was yesterday or something, and I had a look as well. Yeah, and it worked. So there you go.
I see. I think, Andrew, you know what? I think we should collect some money and give you like a I don't know, $500 a gift card for the App Store so that you can start buying, like, you get used to the idea of buying small apps that look cute, are nice, like there has nice color buttons with a nice shade and everything else. And I think your heart will soften for Apple.
Oh my god. I feel like I'm being preached at over here.
Well, but actually, jokes aside, like this is what they do. When I bought the Retina MacBook, they included, I don't know, I think 250 euros worth of Apple Store credit, which basically means that they charge me that money with the initial purchase, and that's how they try to hook you. But yeah, I agree. Apple is annoying, and again, I personally never hit many of these issues because I've never done systems programming in it. I was running Python, JavaScript, Java, this kind of stuff mainly. But yeah, once control over the system becomes more important, then you start seeing that what before was a good Linux surrogate for you, now it's not a good surrogate anymore. I think with the Redis project, I think I remember one day Anti-Reds also tweeting about something about this. I think it was about compiling Redis. The compiling Redis on Mac for some reason would like cut off his audio because something would like hoard some kind of resource and and then how you can keep up. I don't know, something like this. But yeah. So let's see if there's any other questions.
I've got one more anecdote, and I'm trying to remember this. So because he mentioned that for me on the DTK things were working, and that was because it turns out that the OS version that I had was busted for some reason. I couldn't update. I couldn't do anything. Like I couldn't install the new Xcode. If I installed it, it wouldn't work and stuff, right? So I leased, and this is a proper lease, right? I leased. And this is another thing that I think Apple is the only company on the planet that can make you do this. So I had to shell out like $500 to get a Mac Mini that I have to give back. Obviously I don't get the money back, so that's awesome. So I have the privilege to work on the Mac Mini for a year and then just to give it back. I was like, awesome, that's perfect.
That is insane. I mean, I first of all thank you for doing that, because you did awesome work, and you paid for that with your own money, and you just took that on, and then we all get to have the benefits of it. So that's awesome. And then also it's just like, how do they get people? They're getting people to pay to overcome the obstacles that they created, and then you don't even get to keep the hardware.
Right,
that's insane.
Right. Oh, by the way, it's actually not 500. Right? So it's actually 600, because as Frank mentioned, you have to be a developer. To be a developer, you have to subscribe. To subscribe, you have to pay $99 or $100 now. A year, right? Anyway, this aside, so I had many chats with Frank about this, because the stuff was just working for him and he could update and stuff, and I couldn't. And this is the best bit. So imagine that you are a Linux developer, or you develop an app or something. You don't have a Mac at home. You get the DTK. To restore a DTK, you need another Mac. That's it. You need them basically what's it called in electronic engineering? Oh crap, I forgot. Actually, this is my degree and I forgot.
A programmer.
Daisy chaining, right? Oh. No, you daisy chain, right? You daisy chain stuff. So basically, if you have you got a battery and you just want to plug some stuff in, then you're just going to divide the voltage and just daisy chain everything together. And this is exactly what you do here. You take two Macs, you plug them in with USB-C, and then you pray to God that you're not going to break it. I was like, really? So thankfully I had a Mac at home, but then I had to. So my personal Mac, I had to upgrade to a beta program to get the soft that is not supported yet, so that I could restore the DTK. And then pray to God that actually everything is going to work. Hopefully it did, but Yeah.
But I mean, the DTK was just a prototype, so it's okay.
Yeah, $500 prototype. Thank you.
Yeah. The Apple experience, Prot is saying in chat, pretty much. Well, it can be everything. I don't know. I think open source has to step up. The only thing that comes from me is that honestly, for me personally, the equation in favor of Apple is starting to change a little bit. Like this code signing thing is really annoying, and the more things pile up, the more developers will think of moving somewhere else. And at the end of the day, that's pretty much it. Nothing more. We'll see how it goes. So,
I want to see more ARM out there. Honestly, it's actually it's a really good experience, even coding for. I know it's more difficult because of the fact that instructions are fixed length, but and you have to twist your arm once or twice, but it's really good. It's really cool architecture.
Nice pun.
Oh, by the way, so Jakub mentioned
it was not intended, but
Jakub mentioned that compiling an LLVM on a MacBook Air, Apple Silicon, takes 20 minutes. Andrew, how long does it take you to compile on Linux?
To compile LLVM? I have a pretty beefy laptop. I think I can hit or beat that at Mark.
Okay.
It's not. I should probably be more precise here. It's not the entire LVM. It's only the stuff that we need for Zig. So that's Clang extra tools plus LD, because we don't need all the other crap, right? Oh, and this is. So I gave you a present, Andrew. Now I'm gonna take it back. Sorry, apologies. There is LVM 11.01 release client 1 that's out there, and I actually used it, and guess what? It's not been patched yet. So any of you Mac users, install from Homebrew, because you're gonna still have to apply the same patches that Frank and I found for you, because LVM config is not fixed. Yay!
But we will be able to apply those patches to the Bootstrap repository,
Right. Yes.
and that's the one we're using to produce the tar balls. So if you use that, it will work, right?
Yep.
Yeah.
Yep. Yeah. If we do this, then it should be fine.
Also, I wanted to point
so,
out with the new headers that we have, we actually can use that project, the Zig Bootstrap repository project, to cross-compile Zig. It's to bootstrap Zig, targeting Mac OS on any platform. That now works. Or I tested it on hosting it on Linux. Once we have that one extra thing to your post fix up thing that does the L system.
Yeah.
That's a cool milestone.
Yeah. So that's true. So if we fix this, then we're done. We're good. I was gonna say that you've got a big laptop. I also have the I've got a MacBook Pro, the 16-inch. I think last year version or something. I can't remember. It's got i9, 10th generation. So it's got 16 logical cores, right? It's pretty fast, and it's actually slower than M1. It's so sad. I mean, obviously I didn't run the benches yet, proper benches, but it feels slower, especially if you compare core to core. It's insane. So at least that's a really positive thing about M1.
Nice, and
that's cool.
I think.
Yeah.
Sorry, Andrew. No, you go.
Oh, I was just going to respond. Yeah. So on my laptop, I have the Intel i9-9980, 8 core with hyperthreading. So I think that's the same thing you're talking about.
Yeah, probably similar. I'm not sure whether Apple. You might have a better a cat in the sense that you might have the better wattage on the CPU. I think Apple was picking really low wattage Intel CPUs, and that might be the thing.
Yeah. I think I saw a tweet by Frank, who tweets everything that's new. I think, Frank, you tweeted a leak that a new CPU M1X, I believe, for the new Mac has leaked. So are you going to buy the new MacBook Pro 16-inch?
I absolutely will. I mean, it looks super fast already, the good old M1, so the next one's going to be even faster. But, you were discussing about speed, so I got an A9 something as well. It takes about an hour to compile LLVM on my laptop. But the main reason is that after 10 minutes, it starts to get hot and the CPU starts to throttle. So it's super fast at the beginning. And as the temperature gets higher, it gets slower and slower. And I think that this is something that doesn't happen on ARM CPUs. This is the main difference.
Yeah. Right. I believe that the what's it called? Production? Oh my god. The nanometer, the size of the silicon chip that Intel is using for the CPUs are why am I missing this expression right now? Sorry, but I think they have a transistor every 5 or 6 centimeters or 5 or 6 meters even. Where, jokes aside, their process is kind of lagging behind, I believe, compared to I don't know what it is for Apple Silicon, but I think AMD is 5 nanometers, right?
So it's M1.
So I think AMD is 7. Yeah,
okay.
And
I think Apple Silicon is 5.
Yeah.
I'm pretty sure it's 5.
Yeah, well, Intel is
anyway,
15 centimeters.
Frank was saying about the throttling and stuff. This, the power supply of the MacBook Air, and it's I kid you not, it's 30 watts. I'm not gonna bring the one for the MacBook Pro because it's definitely larger. But I got it. I was like, is that for an iPad? So yeah, that was a big surprise.
Right.
So the power draw is very low, is what you're saying, right?
Yeah.
I see. Makes sense. Yeah, Nipsey is saying centimeters. Yeah, it's an hyperbole.
Hey, does anyone know what is the amount of watts they give you on a typical airplane? Because I've had laptops before that I was able to charge, and also ones that I wasn't able to charge. I bet someone in the chat will know.
I'm not sure. Maybe 60 watts per hour? So I'm not 100% sure. I think 60 might be a decent guess, and I think 60 might be at the border between some things being able to charge and some things not being able. But I'm not 100% sure though. Yeah, not watts per hour. Watts, that's it. Anyway, so any other anecdote or anything else that you guys want to say before we call it a day? People thinking. Let's give them a second.
Well, we were talking about Apple controlling the operating system.
Yeah.
What they do control is not just the operating system, it's actually the whole ecosystem. Look at this. All right, I just bought this. This is the new HomePod Mini.
Yeah.
Pretty cheap. However, if you want this thing to be useful, you need Apple Music. And if you want to control it, you need an Apple device, like this one. And if you want
Apple glasses and stuff,
move to a different place and keep listening to what you were doing, you need an iPhone. And since you have pretty much everything, you need an Apple laptop. And because everything works really well together, you need this as well. And this is how you got hooked, actually. You just buy one Apple item, and then you're like, okay, this is going to work really well with my iPhone. And my iPhone is going to work really well with this, and so on and so forth.
Yeah.
So they control the whole thing. I mean, I can use Spotify or whatever with this, but this is not going to be the same experience than if I use just Apple products. Yeah.
And they're pretty good at it, right?
They are really
the
good.
ecosystem. I think they're the best in actually giving you this experience. That's true. Yeah.
Holy shit.
But then again, I think it was Frank who posted a tweet. Maybe it wasn't you. I can't remember. Somebody actually managed to finally get like SSH access to a HomePod. So somebody I think managed to jailbreak it, which means they can actually do more stuff. You can actually see what's inside rather than whatever they give you. So.
Yeah, by the way, Frank, that's a really good point for good or worse that is. But I mean, it's nice. Like there was Isaac Yamamoto the other day tweeting that he was asking about what's a good way of copy pasting something from your mobile device to your computer. And if you don't have anything Apple, I guess the shortest path is using an instant messaging app. You send the message to yourself, and then you access the same messaging application from your desktop. If you don't have WhatsApp, if you have WhatsApp, you can kind of do that too, but it's even worse. On Apple devices, copy from one, paste in the other. You're done. It just works.
I'm going to pull Frank here, and I hope that he's going to give his story about Airdrop, because that was actually very informative as well, right? You love Airdrop, so feel free to jump in.
So yeah, just for an anecdote about Airdrop. I'm a fashion photographer, and when I do fashion shows, right after a presentation, a lot of models come to see me because they want to get the pictures. And I just use Airdrop for that. It's absolutely amazing. Everybody with an iPhone can get the pictures right away. And that only works with Apple. Yeah.
Are we going to get paid?
I think people pay for convenience.
Apple, if you're watching, yes, we roasted you a little bit in the beginning. Yes, we have one guy here who is supposed to be the counter voice so that we look well balanced, but wink, wink, throw Apple hardware at us. Thank you. I don't know. I think we are not. I think we are too honest and natural to actually be good Apple. I don't know, faces. But the integration is real, and even for all these things, it's not like Apple invented them. I remember that you could copy files over Bluetooth even before Apple came out with AirDrop, or actually I don't know the precise timeline, but it's not something unique. The problem is that Bluetooth has always been crappy in so many ways. Headphones, I don't know, maybe today it's different, but before I switched to the Apple ecosystem, because I too have the freaking earbuds and stuff. But I remember pairing my headphones over Bluetooth with two different devices, annoying, sharing files over Bluetooth, janky, I don't know. Not everything was worse, but things haven't improved much, and Apple has just been able to improve. I like how I get a call and my phone rings, and and my computer rings, so I can take the phone call from. I get a call, and I can take the phone call from my laptop, and it just works. That said.
Actually, I want to give a counterpoint here. When
Yeah.
I'm at home and suddenly like 5 devices start ringing at the same time, it's pretty annoying. So I'm just, this is one of the negative things.
You need more devices. At one point, then you start hearing this global ring. You don't care anymore.
Yeah, thanks. I thought I need less. Okay.
You need an Apple chip. So.
Fewer, no less.
No, yeah, that's true. I think you can configure this, but like the fact that you can interoperate, like the ecosystem is good. It's a trap. It's a honey trap, but it is what it is. And that said, I remember that the only software that gave me an experience that for me was comparable with what I'm getting with Apple was Nokia at the time where it had Symbian, and you had like a Nokia PC Suite installed on your computer, and you could do a lot of good stuff with that, old times, I guess, by today's standard. But anyway, this is where we are. Andrew, you don't look happy about where the discussion is going.
I'm just anti-advertisement.
Well, you know what? I think these are the real takeaway is that the open source, and I think this really, it's a good way for even ending the show. The one good thing that Apple is doing is that they care about the end user experience, and in open source, we don't always have that as the center point of what we are doing. And I think that is a problem that we need collectively to address. And I think that Zig, as you said earlier, by making one of the Zig Zen points, and as you already said multiple times, by being centered on the final user, I think that's the point that you need to hit so that you can then help people break away from the Apple and in general, like closed source, closed environments, and walled gardens, and all these kind of monsters.
Well, I definitely agree that we want to focus on the end user experience. I don't agree that that's what Apple is doing. I think that Apple is using the end user experience as a means to an end, and that end is obviously profit, and they're winning. They're winning capitalism, so good for them. But I mean, think about this M1 stuff, right? Like what they did, earlier in the stream, people were actually confused, like, oh, why does the code signing only happen on ARM and not the other one? Like, I can answer that for you. Here's what's happening. They want to do all this stuff that's going to help them make more money, but it's a worse user experience. Like Jakub bought this laptop and it doesn't even work. He has to run find and code sign every binary before he can even use his computer. That's not focusing on the end user experience. But what they want to do is they want to do this thing where they're going to change how things work so they have more control in the ecosystem. But they know it's going to be bad for the user experience. They know it's going to be unpopular. So they're doing it at a strategic moment, right when this new hardware is coming out, and that's all people can talk about. The performance, the low heat, all that stuff. It's like a sleight of hand, like a magician's trick, where they're making you look at this cool thing over here, and then over behind your back, they're just like taking away that thing that now you're not looking at. So do they create a good user experience? Yeah, they do a pretty good job. Things generally work, and that's how they can get you to participate in the ecosystem. But like, don't be fooled that that's their goal, right? Their goal is to get to open your wallet and dump it all out, right?
Yeah, I agree. But we need to be able to match that. Otherwise, you can't even blame people for choosing, I guess, the least of all evils. Again, it depends on your use case. But I agree 100% with your point about the magician trick. The problem, though, is that they can afford to do that because they got they provided so much value on one end that they can then play these tricks. If it was somebody else, probably it wouldn't work. But in any case, this just goes to show that we can do better, and at the very least, if we don't try to play weird tricks, it means that we can reach a higher ceiling even from the software point of view. So something, I guess, to think about for the people watching.
Yeah, I mean, to turn it to more a positive note, as far as Zig is concerned, the end user experience is our actual goal. That's the difference between Zig Software Foundation and Apple, is that the end user experience is the goal. There's no money goal. The money is a means to accomplish that goal rather than vice versa. So that's the positive note that we can end it on.
So if Apple is listening, give us the copyright draw, and we're gonna be fine for now.
Yeah.
as a start, and then we can talk about more stuff. So.
Yeah. Okay. Any final words? Let's do maybe a round for any closing thoughts. Frank, do you want to start?
Yeah, I'm just super excited about ARM CPUs in general, and I saw that the M1 has some interesting instructions to speed up crypto. So that's super exciting to me, and I hope to be able to use this instruction for Zig to speed up SHA-2, SHA-3, and more. So that's pretty cool, and one of the reasons I'm excited about these new CPUs. Yeah.
Okay. Andrew?
Yeah, I just, despite my words a minute ago, I got one of these laptops coming thanks to a generous donor, and I'm very interested in making the Zig user experience to be on par with how it is everywhere else.
Awesome. Jakub?
We're getting there.
The poor guy that is doing the actual work. Yeah, we're getting there.
Actually, believe it or not, I did enjoy it, except for the fact that there's no dogs. But now I guess I know where to look. The other thing I wanted to point out, because Frank said that there is some tweaks to the ARM instruction set. There's more because the calling convention is different as well.
Jakub, you are the documentation right now. I hope you realize that.
So I promise, LVM guys, I'm gonna come over to you and I'm gonna port the stuff over. I just don't like C++, but
Give them a Zig file. And,
yeah,
and they link to it.
I'm sorry, but that's exactly what I was doing to the Go guys, and everybody ignored me. So I was like, oh, okay.
Okay. So I think we can end the show here then. Don't go away, fine guests. Stay here while I do the outro, and then maybe we can exchange a few words after I play the outro. So thank you everyone for participating. This was awesome. I hope this was also interesting for the viewers, and I'm sure YouTube is gonna also love this discussion. I think it's interesting to see how a open source project tackles these issues, which are really real and contemporary. And as you can see, not everybody feels the same way about Apple, but we all share a common final goal, which is to get a good user experience for Zig users, no matter what the platform is. People have different life situations, and they make different choices for their own reasons. And yeah, I hope this was interesting for all the people watching. Alex says 4 Windows users, and I think we have more than 4. Like we have, you were using Windows. I don't know if you switched now, but there's Windows, there's you, King is using Windows. There's at least a few people that we know of.
I use all 3, like Andrew. I don't use BSDs because I have a hard time actually getting them to work, but I use Linux, Windows, and Mac.
So yeah, and so that was fun. Next showtime is going to be next week. I put in the final screen a tentative date of the 5th, but I haven't agreed on it yet with Matt Knight, because Matt Knight is going to talk about his package manager. And the second part of that showtime episode is going to be a event like we did for the 0.7 release, where I don't have a name for it yet. I was thinking something around the lines of a show us event, but the idea is like you come in voice chat in Discord and you bring us something for us to discuss. So maybe you're working on a project, showcase your project. You can enable desktop sharing and show us what you're working on. You just want to ask a question, come ask a question. You want just to make a comment, come and make a comment. So it's going to be something like this, because also next Showtime episode is going to be the last episode of 2020. We're going to take a break. There's going to be the holidays coming up. As I said, I depleted almost my speaker pool, so no speakers, no showtime. And then we can all take a break and come back, re-energize in 2021. Hopefully, changing the year will make things better. I don't think so, actually. Actually, let me tell everybody one thing. I remember this from school. These are all the things that you learn in school that you're supposed to learn in school, but then forget about and end up being an ignorant adult. But there was this story about a calendar man trying to sell calendars to people. And at one point, the calendar man finds somebody on the street and asks them if they want to buy a calendar. And to entice them into buying the calendar, this guy says, the seller says, "Oh, you should buy a calendar for next year. Next year is going to be amazing for sure, and you will want a calendar." And then the person says, "Well, but how was this year?" And the seller says, "Well, not that great." "And how was the previous year?" Not that great either." "And how was the year before that?" That was also awful too." And at the end, the guy, out of compassion, just buys the calendar. I remember this story. Anyway, I'm sure 2021 is going to be so much better than everything now. So I guess see you all then.